Okay, this question is asking us to consider test data for two different calculus classes, and it's asking us to calculate the coefficient of variation for both sets of scores. So the coefficient of variation, or what we would say CV, is going to be a measure of variability, and it's comparing two or more standard deviations. So you have for a sample data, the coefficient of variation is going to be given by the sample standard deviation over x bar, so our mean, times 100%. For a population, it's pretty much the same formula. It is population standard deviation over mu times 100%. So population standard deviation divided by mu, our mean, over 100%. So let's take a look at this. So we have test one data for two different calculus classes. So a mean of 65 and a standard deviation of 15 for test one. And so it looks like we have to determine if this is sample data or population data. Actually, it doesn't really matter because it's the same formula, but I believe that both of these would be population data because it's the entire class of each one. So our first one for 8 a.m. class, we have, 8 a.m. Okay, so for our 8 a.m. class, we have a standard deviation of 15 over a mean of 65. And then we're going to multiply that by 100. So let's see here, 15 divided by 65 times 100. So it's going to give us, let's see, round our solutions to one decimal place, so 23.1. And then we have our 11 a.m. class, has a standard deviation of 12 and a mean of 69. So let's see what that gives us. 12 divided by 69 times 100, 17.4%. Okay, so those are our coefficients of variations for each of those classes. And then we want to know which class has the greater variability. That would just be the one with the greater percentage. So the first class here, the 8 a.m. class, has the greater variability. Okay, which just means the spread is greater. Obviously, we see that with a higher standard deviation.